So here is an exercise problem where angle of elevation of top of a tower from 2 points at a distance of 4 meter and 9 meter from the base of the tower and in the same straight line with it are complementary. Show that the height of the tower is 6 meters. So basically, there is a tower. There are 2 points at distances of 4 meter and 9 meter from the base of the tower. And both the points are in the same straight line. And the angle of elevation is complementary. So basically, we don't know the angles. The height of the tower is given, which is 6 meters. So we have a tower here. And there are 2 points, A and B, on the ground, both of which are in the same straight line. And they are at a distance of 4 meter and 9 meter. Right? If this is the base of the tower, the first one is at the distance of 4 meter. Second one is at a distance of 9 meter. This is the top of the tower. So the angle of elevation is not given. We don't know the angle of elevation. Height of the tower is given, which is 6 meters. So the height is 6 meters. Let's call this as P and Q. So height has been given, but we'll have to prove that the height is 6 meters. So we'll have to prove this. We cannot use this in the calculations. We'll have to prove that it is 6 meters of height. And one more clue here is both of these angles are complementary to each other. That is, this angle and this angle together are 90 degrees. So if you add this angle and this angle, it's going to be equal to 90 degrees. We have two triangles, triangle PQA and triangle PQB, right? Let's call this as angle A and angle B. When you add both of these angles, it's going to be 90 degree because both are complementary. Now, let's take first triangle, triangle PQA. We'll have to take tan formula because we'll have to prove the height, which is nothing but the opposite side to the angle, and the adjacent side is already given. So let's assume, let's call it as angle A only, right? Let's assume it as A. So this is equal to tan A, we'll call this as angle A and angle B. Tan A is equal to opposite by adjacent. Opposite is, we don't know, it is H. We'll keep it as H because we'll have to prove through calculations that it is going to be 6 meters. Adjacent side is 4 meters. Adjacent is nothing but QA and opposite is PQ. What is tan A? We don't know what tan A is. So we'll leave it like this. So we'll isolate H here. H is equal to tan A into 4. Let's call this as equation 1. Let's take triangle PQB now. We'll call this angle as B. So tan B is equal to opposite by adjacent, which is opposite to tan B is PQ by QB. PQ, we call it as H, and QB is given as 9 meters, right? So we'll isolate H. H will be tan B into 9. So let's call this equation 2. Now what do we do? How do we proceed from here? So one hint or one clue is whenever you have to prove the height of the tower or length, we'll have to take these two equations. In any problem, right? We'll have to take these two equations. We'll have to either add them or multiply them. So in this case, we'll multiply them, right? Let's multiply 1 and 2. In some cases, we'll have to add, right? Where you have to find the length of the adjacent side. That case, we'll have to add. But in this case, since we don't know the angles, we will multiply both of this, right? What we will get? We'll get H into H will be H square is equal to 4 tan A into 9 tan B. 4 into 9 is 36 into tan A into tan B. Now, tan A and tan B. Now, angles A and B, if you add together, is going to become 90. So, angle B or B is going to be 90 minus A, right? So basically, if this is A, this is going to be 90 minus A, right? Because both the angles are stated as complementary. So what we will do, we'll substitute, we'll keep tan A just like that, and we will write tan B as 90 minus A. So this will be 36 tan A. Now tan 90 minus A. What is tan 90 minus A? It is cot A. Similarly, if it was sin 90 minus A, it will be cos A, right? So this is going to be cot A. Now what is cot A? Cot A is 1 by tan A. So let's write that. Is equal to 36 into tan A. Cot A is 1 by tan A. So this is going to get cancelled and we are going to be left with 36. So h square is 30. So h square is 36. So h square is 36, which means h is square root of 36, which means h is 6. So we proved that h is 6 meters. So hence proved.